discuss the arena of technology undergoing a continuous metamorphosis in the current decade with the scenario changing at a rapid pace, an evolution that is propelling mankind to greater heights. So, in order to keep the curious minds updated about the multitude of new technologies, gizmos, and theories, we bring forward a new initiative called the Forum for Ideas on Science and Technology (F.I.S.T), which would comprise of a plethora of events ranging from webinars to workshops. This initiative aims to create a more conducive environment in our institution for carrying out projects utilizing the technologies discussed, utilizing and hopes to promote constructive discussions about the same. This evening, as we learn about hybrid electric vehicles from the masters themselves, let me first give you all a brief introduction. Today's hybrid electric vehicles, commonly called HEVs, are powered by an internal combustion engine with one or more electric motors that use energy stored in batteries. One of the biggest advantages of a hybrid car over a gasoline powered car is that it runs cleaner and has better gas mileage, which makes it environmentally friendly. HEVs combine the benefits of high fuel economy and a low tailpipe emissions with the power and the range of conventional vehicles. There has been an increased demand for fuel-efficient automobiles across the globe. This demand has driven the market for hybrid electric vehicles to exhibit a strong growth during the 2015-2020 period, and looking forward, drawing from the current trend and demand, the market is forecast to grow annually at a rate of around 35% during the next 5 years, 2021 to 2026.
As the world around us progresses to new lifestyles, we realize the need for us to understand the concepts of technology that formulate these evolving methods of life. Our team hopes that by posting this webinar, the audience could be instilled with an interest in the HEV industry. We encourage all the students to incorporate the facts learned into projects they might be constructing in future. With this, let me introduce you to our first speaker of this evening. Please welcome Dr. Naveen Kumar Marathi. Good evening, sir. I hope you are staying healthy.
Yes, thanks, Aniket. I'm very good, and I hope every one of the participant is doing good.
Yes, sir. Good to hear that. So, Dr. Kumar is an eminent architect at the Electric Vehicle Center for Excellence, Wipro Limited. He has also an experience of more than 9 years in power electronics and control and over 4 years of automotive R&D experience. Dr. Kumar has demonstrated experience in design, modeling and digital control of power electronic converters, hybrid electric vehicles and their applications alongside good hands-on experience with microcontrollers and their integration with power electronic converters. Currently, Dr. Kumar is working with the latest technologies incorporated during the applications of hybrid electric vehicles and electric vehicle powertrain systems. He has been the senior hardware engineer at Power Electronics R&D department at Valeo, a French automotive organization. He has been contributing to IEEE for more than 7 years. Concisely, he has worked on numerous projects as far as the eye can see in this domain. He is an accoladed personality who has been the chief speaker at several public events. It would be an incredible fortune to spend time interacting with such an esteemed personality. I would now like to hand over the stage to Dr. Kumar to inspire us with his ever influencing words. Sir, please.
Thank you. Thanks, Aniket, and thanks, Datta. And yeah, very good evening to one and all. So, are you able to see my screen?
Just a second, sir. It's not yet loaded. Maybe it's loading. Yes, sir, it's visible. Now you could just start the slideshow.
Oh, oh, oh.
Yes, sir, it's visible. You can just continue.
Yeah, thanks. Thanks, everyone. And thanks, Society of Automotive Engineers, India Division, and especially NIT Durgapur Collegiate or the student branch of SAE, and the organizing team members and the faculty advisor of this particular event. And the participants and ev- every student and the faculty or the everyone who are presenting in the session. A very good evening to one and all, and a warm welcome to the session. Thank you for a nice introduction about myself. And today's session, I mostly discuss on the different powertrain architectures of hybrid electric vehicles. We will see why one needs to go for different configuration or one needs to go for hybrid electric vehicle first of all, and what are the market drivers or which are the major components which are driving us towards electrification or hybridization. We will see different architectures like series, parallel, and what is their configuration, what kind of efficiency they will give, and based on what functionalities different hybrid architectures have been discussed. So these are the some of the things we'll be looking in today's session. Overview of today's session, I'll mostly cover these particular points. A brief introduction about hybridization, then market drivers, why one needs to go for electrification or hybridization in automotive, and different classification of hybrid electric vehicles like mild, micro, plug-in or BEVs, and how these hybrid electric vehicles have been classified. What are the basic functions to classify these hybrid electric vehicles? And we will see different architectures and different configurations inside a particular architecture, based on which what is the efficiency at each configuration one hybrid electric vehicle can give. And we will see the real time vehicles which are having already this particular architectures. Then we will also discuss one or two challenges on EV or hybrid electric vehicle. Then we will conclude. So mostly this session I've kept only major focus is on to the hybrid electric vehicle. So without a delay, so the existing automotive solutions, how it has been divided or configured into. If you see in the automotive vehicle, let's say if you take a simple passenger car or a passenger vehicle, so you might have well versed with the conventional vehicles, and which is called IC engine based or internal combustion engine based vehicles. And the second one, the buzzword in this decade and the future of next automotive vehicles or automotive systems, and the future of next decade I can say, and the people who is going to listen for a while is electric vehicle and the boom for today, and how this electric vehicle has been classified. So there are three different types, or there may be a fourth version of it. So first one, a simple battery powered vehicle, and today there are different
So you're
battery,
muted.
lead acid battery or lithium ion battery or nickel cadmium or different varieties of lithium ion batteries. And today in the market, the latest from the OEMs is Ultium battery. So these are some of the varieties of battery vehicles, and that depends on the battery capacity, battery volume, and different other parameters these battery vehicles will be configured. So apart from the battery vehicle, there are certain hybrid battery vehicles. I can say not hybrid vehicles, it is hybrid kind of battery ecosystem where you will have battery plus ultra capacitor. So why this kind of configuration is required in the hybrid electric vehicle is, one is battery has the high energy density and ultra capacitor will have high power density. With this combination, the providing the starting torque will be very easy when you have this kind of configuration. So many of the researchers have been working and are working in this field. And the third variety, and this may be the future of battery electric vehicles, is battery with fuel cell vehicles. There are a lot of OEMs and a lot of startups who are doing current research in this particular area, and there is a next area is called fuel cell based electric vehicles. So these are the upcoming or latest into the electric vehicles, how they have configured or conceptualized. Next, today's session, we will be mostly concentrating on hybrid electric vehicle or hybrid vehicle. I can say not hybrid electric vehicle here. So this, it is not the term electric. A hybrid vehicle, there are two ways of hybrid vehicle. One is mechanical based hybrid vehicle. Second one is hybrid electric vehicle, electric based hybrid electric vehicle. So the mechanical, you might be very well versed like flywheel or pneumatic or hydraulic based hybrid electric vehicle. And today I will restrict myself with hybrid electric vehicle concept, which is hybrid electric vehicle furtherly classified into different varieties like micro, mild, hybrid, plug-in hybrid, and range extended vehicles. So around 4 to 5 different platforms and how it is configured today in this varieties of hybrid electric vehicle we will discuss. So, what is the major market driver for electric vehicles or different standards of Bharat standard which I might come across today? Today, you might all know we are in the considered stage of Bharat standard 6. How it has been evaluated or how it has been evaluationized because of first and primary reason is CO2 regulation or NOx regulations are impacted us to change from BS1 to BS6 today. Further, it will be changing into hybrid vehicles or electric vehicles. So, the regulations have been imported by Paris Agreement or by different countries at different stages, and today India has been kept a milestone that we have to reach 113 gram carbon dioxide release per kilometer is today's standard by 2021 India's regulation standard. But there are western countries who are far away from us like Europe and the US. They are already very far, like in European region it is 95 grams carbon dioxide release per kilometer, and if you are not posing this particular condition, then the OEMs will be penalized very high on their powertrain machines. So, to make this particular combination of regulation or to meet this combination of regulation, one needs to optimize their powertrain. So how do they optimize their powertrain? So as said in the earlier slide, it may be with respect to battery electric vehicles or hybrid electric vehicles or different optimization parameters into the vehicles. So one of those we are today is under the BS6 BS6 standard, and tomorrow it may be a hybrid or a pure electric vehicle based scenario. So to achieve that, so how to achieve this 113 gram carbon dioxide per kilometer in 2021? So when I need to say about this 113 grams, I need to think about optimization in the powertrain. how do I do that optimization? So there are different ways to do optimization, and one of those are some of those are listed here. Those are like where the maximum loss in the powertrain is happening. So if you see, one of the loss in the energy in a powertrain is there is accumulated around 17% of energy lost in idling mode. So what is exactly an idling? Idling is nothing but when you keep your vehicle in a standstill mode during your situation in a traffic condition. Generally we keep our vehicle stopped in the traffic condition. During that time, if your vehicle is consuming energy from powertrain, then those energy lost or those situation is called idling. So the energy lost during that particular stage is 17%. And today many powertrain or many OEMs are concentrating to reduce this particular energy loss. So with this, there are OEMs who has increased the efficiency by 5 to 6% overall. So one of those kind is like Activa latest models, if you can see in the two-wheelers. And there are 2% of loss in the accessories, and there are 5.6% loss in the drivetrain due to the friction and slippage. And there are 62% loss in engine frictions, and different losses are accumulated at different stages, you can see. But when you do, I have said I can do the energy saving in the idling. But if I directly put those changes in the powertrain, what is the impact in the overall dynamics of the vehicle? So what are the factors I need to consider during the optimization of powertrain? So when I'm doing the optimization in the powertrain, it automatically affect some of the parameters in the vehicle. So vehicle optimization will also happen simultaneously when you're doing powertrain optimization. Some of the points to be remembered when you are doing the optimization in powertrain are your vehicle gravity and rolling resistance, which is the resistance between your tire to the earth, and internal frictions in the vehicle, and aerodynamics model of your vehicle, and vehicle inertia. So these are some of the factors which are going to affect in the vehicle, which needs to be considered in any changes or any modifications in your powertrain architecture. So what is the roadmap which OEMs have been considered to do it? So there are four ways. One is in the vehicle by reduction in weight reduction, or aerodynamic improvement, or tires improvement. And second one is in the engine, downsizing, exhaust gas recirculation, gas direct injection, or variable valve timing. And the most important one, and which is most needed one, is in electrification. So micro, mild, or full hybrid, or plug-in hybrid, and electric vehicle. Any of this may also reduce the CO2 emission. And there is other way in the transmission, like continuously variable transmission, or dual clutch transmission, or down speeding or coasting. So with these various types of methods, one can reduce the CO2, and these are the some of the considerations considered by the different OEMs. So today from CO2 130 to 95 or 75 can be achieved at the different stages when and where it is required. So who is going to measure these particular emissions, or who is going to certify these uh, emissions or powertrain certifications, or what is the test procedure that this vehicle is releasing this particular emission in the vehicle? So there are standards called WLTP, which is called Worldwide Harmonized Light Vehicle Test Procedure. And earlier, prior to WLTP, we used to follow NEDC, which is called New European Driving Cycle. And in the Western countries like US, they follow HWY, Highway Driving Cycle, and FTP 75, US Environmental Protection Agency Federal Test Procedures. and what are these test procedures are going to say to us, and why these test procedures are required. So if you take about WLTP, it tests based on four particular parameters. One is the fuel consumption, CO2 emissions, and pollutant emissions, NOx, CO, or different other pollutants, and energy consumption at different levels of powertrain. And how do we test this? WLTP or NEDC. New European driving cycle we used to follow before 2017, and this particular certification is based on theoretical driving procedure, and this has been outdated. Today in WLTP we work with the real time data, and at four levels of stages these driving cycles we test, like low speed, medium speed, high speed, and very high speed regions we will test, and different regions, rural, semi-urban, urban, and during the city mode conditions, we test at these particular regions of four levels of uh, regions as well. And this particular WLTP is based on a real-time driving data, and which will be tested around 22 minutes per cycle with maximum speed of 131 kilometer per hour. But in India, we also impose one more driving cycle called IDC, Indian driving cycle. We generally test vehicles at 85 km per hour as well. So overall, WLTP as European and most of the countries follow this. And in US, there are special apart from WLTP, SWY and FTP 75 they follow. And how do they test? So if you see at different speed and different time, which will be tested according to the a start and very high speed, and they will stop with very frequently, and they will test with a different velocity profiles for this particular test procedure. If you see in the blue one, NEDC used to be tested at 120 kilometer per hour, and whereas WLTP will be tested at 131 kilometer per hour with a real-time driving data on road, it will be tested. So these are the test specifications which are going to certify the emission and of the CO2. And coming to who and how the OEMs have been transitioning to the clean vehicles in India, and you might have already heard about many of this which I have located here, like in the many Indian OEMs like Tata, Mahindra, or BYD, which is Goldstone BYD earlier, and today it is like Electra and Toyota, and which majorly gives the electric buses, and the Honda, Toyota, and different OEMs have been releasing their models into the market at different stages. And there are the top or SUVs, top end models like Tesla, Audi, or have been entering into the Indian market to deploy their hybrid and electric vehicle models in India. And in 2020 and 2021, we have come across a lot of models into four wheelers and a lot of two wheelers, and many startups have been launching their vehicles. And recently, one of the e-mobility solution provider has been launched the vehicle in India at a uh, very good mileage. So this as the how India is transitioning toward from 2018 to 2020 and beyond, how the vehicle launches have been happening, and how the market is going to update, and how the automotive society of Indian automotive manufacturers are predicting what are the sales in vehicles, total automotive vehicles. If you see by 2026, the projection is 6 crore 32 lakhs vehicles are going to deploy into the Indian roads. And today, this projection might have been increased because of the COVID situation. Everybody has given the first priority to the health, and those situations the everybody is looking for a personal vehicle. So this projection has also been increased, and by a maximum projection it may reach by 7 crore 44 lakhs vehicles, and a median of 6 crore 88 lakhs vehicle may deploy onto the road with a GDP of 5.8%. So this is a overall a basic and why and how the projection of hybrid or electric vehicle or a conventional vehicles will take place at a growth in India is projected till now. And without a delay, we will move straight away into our today's topic, hybrid electric vehicle and its architecture. So how it has been classified. So if you see, I have classified here into the 5 legged stool model, I can say. So the increasing of electrification is going to, from right to left, the electrification in the vehicle will increase from mild hybrid to fuel cell electric vehicle. And today we will restrict mostly from plug-in hybrid and mild hybrid session. And the electrification in the worldwide is here. If you see the millions of cars sold with respect to the years is deployed here. This is mainly for the four wheelers. If you see, by 2025, 48 volts mild hybrid will represent at least 10% of the car market. So this will be the 48-volt mild hybrid will play a crucial role in the automotive revolution and this year by 2025 in fact. And what is exactly an hybrid electric vehicle is nothing but, or hybrid electric is nothing but, it is a combination of your combustion engine plus an electric machine. So how this electric machine is going to assist this engine will classify different hybrid electric vehicle topologies in the hybrid electric vehicle. So based on the machine, where it is kept and how it is going to function, that will describe it is a mild hybrid or a micro hybrid or a plug-in hybrid functionality in the hybrid electric vehicle classifications. So the first commercial hybrid electric vehicle you might have heard. If you have not heard, the Toyota Prius is the first commercial hybrid electric vehicle in 1997. Prior to that, in the 19th century, in 1900s, the first hybrid electric vehicle was in hybrid electric vehicle, and the concept of hybrid electric vehicle has been started with the phenomenon of regenerative braking in the electric vehicle. And at that time, the battery in the vehicle or electric vehicle was 6-volt battery used to be used. They used to use with a lead acid battery. And today, till now, there are more than 11 billion Toyota hybrid are sold across the worldwide. And there are many other OEMs have been entered and selling their hybrid models in the market today. And how the hybrid electric vehicle powertrain is classified. This is a source from US Department of Energy. And in the normal conventional vehicle, you might have seen internal combustion engine, exhaust system, and there are common systems like thermal cooling, transmission, and everything. When you coming to the hybrid electric vehicle, there are certain implications, certain components will be added to your conventional powertrain. Those are most important one: power electronics controller, DC-DC converter, and an electric generator and a traction motor with a small traction battery pack will be added. So these are the 5 extra components will be added in your vehicle when you compare with a conventional, simple conventional or simple hybrid electric vehicle. And you will see there is an extra battery which is an auxiliary battery which generally has in the conventional vehicle as well to power your internal infotainment system in the vehicle. So we will discuss in detail how these configurations happens and how your hybrid electric vehicle powertrain depends on what are the features which differentiate your hybrid electric vehicle powertrain. First one, as I said, idling stop, or which is nothing but stop start system. During the vehicle stop in the traffic condition, your engine should not, or your vehicle should not consume any energy from your engine, which is called idling stop condition. Second one is energy recovery through braking mode, which is called regenerative braking, which is nothing but when your vehicle is in the cruising mode, your energy should recapitulate into the battery through regenerative braking mode. During that time, your bidirectional converter will activate, and which converts your AC energy into DC. Then electric only propulsion, that is nothing but your IC engine will not work, and only your electric machine will propel your traction unit and run for certain amount of distance. Fourth one is electric machine assist. Your machine is going to assist your combustion engine for certain re- torque requirements or power requirements at certain conditions. So these are the basic features of hybrid powertrain. There are, apart from this important feature, there might be some extra features which are required for hybrid electric powertrain, but these four are very important. And how do we classify different hybrid vehicles? So like micro, mild, full hybrid and a plug-in hybrid. And if you see, I have listed down here, there are some features. First one, automatically stops or starts the engine in stop and go traffic, which is nothing but idling stop. If this only feature is consist in your vehicle with your IC engine with an electric machine, then it is called a micro hybrid. If you see, Seatron C3 consists this particular feature of mild hybrid electric vehicle. Then, along with the first point, if your vehicle uses regenerative braking above 24 volts, like today it is most commonly 48 volts, and it assists the combustion engine during the starting, which is called as a mild hybrid, and Honda Insight is one type of variety in the mild hybrid philosophy. Then, along with this particular 3 points, if your vehicle can drive at some times using only the electric machine, is called full hybrid, where your electric machine can drive for certain amount of distance. And if along with these four features, if your batteries can recharge from external charger or onboard charger, you can call it as plug-in hybrid vehicle, where you can put a plug-in onboard charging port onto the vehicle and a charge, which is called Chevy Volt vehicle, which has that particular feature. And here you can see Toyota Prius is parallel hybrid architecture, whereas Chevy Volt is series hybrid architecture. What are these architectures? We will discuss in just in next few slides. And who are contributing for this particular powertrains, and who are the market leaders in the powertrain component providers? If you see Borg Warner to Valeo, there are different organizations. Apart from this, there are many other organizations contributing to the growth of powertrain, or they are the major suppliers for the major OEMs. They have been supplying into the IC engine, mild hybrid, hybrid and battery electric vehicle components in the market. They share the maximum share of powertrain component supply for the OEMs today. And what are the powertrain requirements? Means how do you select which engine, what is the engine capacity unit, or what is the machine capacity unit, and how it is going to require. So when I go with a vehicle in the market, customer is going to look for some of the feature or the technical specification requirement in the vehicle. So from there, the requirements of the powertrain will come. So first one is, the requirement of powertrain is to develop sufficient amount of power to meet the demands of electric vehicle or vehicle performance, carry sufficient energy on boarded to support vehicle driving in the range, and demonstrate high efficiency with low fuel emissions. These are basic requirements for any powertrain which a customer look for. Then broadly, hybrid electric vehicle is named as which has more than one energy source and energy converter, which is called power source. is nothing but an hybrid electric vehicle. And there are different ways, and we will take simple parallel architecture of hybrid vehicle, and I will discuss how different ways of energy transmission uh, transfer will happen from one conversion to one place to other place, and what are the maximum possible conditions to exchange the energy in the next slide. If you see the simple hybrid powertrain architecture, so consider energy source 1 as your IC engine and energy source 2 as a battery, and your load as your wheels are differential in the vehicle. And you can call summation as a transmission, or where you will couple your energy source 1 and energy source 2 over here. The energy converter here, energy converter, you can call it as the here, which may convert from your DC to AC or AC to DC, and there may be your electric motor and electric generator over here. So how the conversion will happen? First of all, so to drive this load, the first possibility is energy source 1 only can drive the load first, and energy source 2 only can drive the load, and it's 2, and energy source 1 can drive the load. Simultaneously, energy source 2 can charge the energy source 1 can also charge this energy source 2, that is battery. This is the third condition. And energy source 1 can drive the load. Simultaneously, if it is in the cruising mode, this load or the energy source 2 will charge in the regenerative braking mode, that is called recapitulation of your energy, that is fourth way. And energy source 1 and energy source 2 combinedly drive this load during the peak torque requirements or peak power requirement at the load. And sixth condition may be energy source 1 itself drives and recapitulates energy, and there are other few conditions as well. We will see the next slide. So these are different ways of the energy exchange between your source 1 to source 2 and to the load, and this is how different levels of power delivery happens between your powertrain 1, powertrain 2 and the load. So how the classification of hybrid electric vehicle happens, or the main agenda of today's topic, architecture definition of hybrid powertrain. So the architecture of powertrain, hybrid powertrain, is classified majorly into four, but in the market you may see popularly two, which is series hybrid and a parallel hybrid configuration, and there are two more, series parallel hybrid and a complex hybrid structure, which are not much popular or at the research stage itself. So series hybrid architecture, if you see, you will have a IC, the connection will be from electric motor only to the transmission, whereas in the parallel hybrid, IC engine will also connect to transmission, electric motor will also connect to the transmission. So the power conversion happen in the series, you can see, first from IC engine, generator will convert mechanical energy into your electrical energy, then convert your electrical energy again at the DC into AC furtherly to drive the transmission unit. So whereas in your parallel hybrid, the conversion is from IC engine to transmission, or again IC engine to the power converter. That depends on requirement. So in the series parallel, you will use both the ways. IC engine will connect as well as it will charge the battery. And there are three machines used in the complex hybrid, which is not much popular. And series parallel may be used much used in the uh, like commercial vehicles like buses at least. So if you see in the series hybrid, there are two electric machines are used. One is the generator and the motor. Whereas in the parallel hybrid, you will use only one, which is electric motor in it. So we will discuss in detail this series hybrid and a parallel hybrid, who will give the actions, how the powertrain will occurs and how the control strategy will work in this hybrid series and parallel. And there are certain configurations in the parallel hybrid. There are 5 different configurations exist in the parallel hybrid. We will also discuss with those and how those configurations have been evolved. So if you take a simple series hybrid powertrain architecture and which is furtherly demonstrated here, uh, the major modification in the vehicle will be over here, and it is like from the fuel tank engine, then there will be a generator which converts your mechanical energy into electrical energy. Then you will have a rectifier which stabilizes your DC link voltage at here, then which furtherly convert into your motor furtherly motor control or converts your DC into the AC required AC requirements of traction motor, and which controls this traction motor for a various speed requirement and various machine requirements to drive this mechanical transmission or wheels. And you can see the first energy conversion is from engine to mechanical transmission, and there is an other transmission which is hybridization or electrification happens from battery to your DC DC conversion happen again from motor controller traction, and the mechanical transmission will happen. So one mode is like this, the other mode is in this manner, and the third mode you can see it will also charge the battery as well as it will transmit transfer the energy to mechanical transmission. And there is another mode, one is in the transmit, it will transmit the energy, and the other way the regenerative braking mode may happen and charge the recapitulation mode which is energy built mode. And there are 6 particular operations we have here: pure electric mode, pure engine mode, a hybrid mode, and engine traction plus battery charging mode, a regenerative braking mode, battery simple charging mode, and hybrid battery charging mode. So these are the different varieties of operations can be performed onto this series hybrid architecture. And how exactly this energy will transfer to your wheels and who is going to give the commands? If you see, the typical series hybrid powertrain will work like, so here operation commands will come. Who will give this operation command? So this operation commands will come from the driver. So that may be a acceleration or the braking mode. If you give the command acceleration, then vehicle controller will immediately speak with your engine controller and peak powering source as well as the motor controller to provide certain amount of power requirement to accelerate the vehicle at a required acceleration level or required deceleration level. And if you require to give the operation commands from the driver or the user is the braking mode, and it will directly give the signal to the vehicle controller. Further, vehicle controller will give the instruction to the motor controller and mechanical brake so that the engine speed will come down as well as the braking will happen in the vehicle wheels. And who is this peak powering source? Is nothing but who powers your battery, is your main battery for the traction battery to power your motor controller or your motor during the energy electric assist mode. And this is how the conversion, the electric conversion, you can see it is bolded here, and the mechanical coupling or mechanical connections have been shown with a double line, and single line are signals over in this high level architecture diagram. Further, if you move onto the parallel hybrid structure, if you see from series hybrid is having 2 electric machines. One is the generator and second one is the electric motor. And if you differentiate in the parallel hybrid, you will have only one electric motor in the configuration. And your engine will directly connect with a mechanical coupling, and as well as your motor will also directly connect with your mechanical coupling. How do your energy will exchange from your engine to your battery? Here your motor will work as an starter generator which can work as a motor during the propelling mode and generator during your recapitulation or regenerative braking mode. So how the energy will transfer from fuel tank directly to your transmission and differential, and the other way you can also charge, you can also drive only in the pure electric mode, which is through battery, and the energy recapitulation may happen during the regenerative or during the charging mode from the engine to the battery. So what are the different operational modes which we can expect here are hybrid traction mode, both engine plus your electric machine can assist to drive the vehicle at a certain speed. Then engine alone traction mode and motor alone mode, regenerative braking mode, and battery charging from the engine. So these are typical modes of operation in the parallel operation. And if I see how the commands will come again in the same fashion, the vehicle customer user can give the commands acceleration or deceleration or braking mode. Based on this vehicle controller will activate engine, motor, and the brake controllers depends on the requirements. But how this control algorithm will work, how exactly internally this vehicle controller will behave, that we can see in the next slide. So if you see the acceleration pedal, when it gives the signal, then it will try directly goes the command to the engine power command and the motor power command, which is in the propelling mode. And simultaneously, depends on the power requirements, the engine and motor can give the power to the wheels, or motor alone can give the power to the wheels, or motor can wheels can give regenerative power to the back to peak powering source. And if it is a braking controller, then again the braking command will come and friction battery and friction brake controller, and finally it will actuate the brake mode. So these are the control scheme operation for the parallel hybrid architecture. So that depends on the command, this any operation either in the only pure engine mode or pure motor mode or combination of motor plus engine mode, it may actuate, or the braking mode it will actuate. So these are different philosophies in the control. But this is overall view of a control, but different control algorithms strategies will be implemented to make your hybrid control unit to activate this particular control algorithms into the hybrid electric vehicle. And again, if you see the parallel hybrid architecture, this is how in a vehicle it looks like. But there are different configurations like P0, P1, P2, P3, P4, and PS architecture. These are the configurations in the parallel hybrid electrification or parallel hybrid architecture. What are these P0, P1, P2, P3, P4, and P5 configuration?
Excuse me,
How
sir.
it is evolved? Yes, please.
Sorry to interrupt you, sir, but we are on a very tight schedule. So if you could sum up within next two
Yes,
to three
last
minutes, so that we can have
slide.
a Q&A session, quick
Yes,
Q&A session.
last slide. It will complete. Okay.
Thank you, sir.
Yes. Yeah. So based on your machine position, this configurations will happen. If you are going to connect your machine like this before your engine, then it is P0 architecture or P0 configuration of parallel hybrid. If it is after the combustion engine or IC engine, then it is P1. If it is at the before the transmission and after the combustion IC engine, then it is P2. And at the transmission unit or clutch, it is P2.5. And after the clutch, then it is P3. And if it is on the differential, you can see on the differential, then it is P4. And if it is in the vehicle, then it is in the P5 or PS configurations of the passenger car or parallel hybrid configurations, I can say. Then how the fuel consumption will happen depends on this particular configurations. The fuel consumption or the efficiency improvement may be up to 15 to 16%, and today it may rate to up to 24%, depends on the vehicle electrification or propulsion. So this is a source from Hybrid Electrification magazine of IEEE, and which is a very good magazine which you can explore majorly on the 48 volts mild hybrid architecture. Then comparison, when you compare from the parallel and series hybrid architectures, parallel has little more advantages over the series, where it doesn't require a generator in it, and the traction motor is smaller, and multi-power conversion stage is not necessary in the parallel, so that the overall efficiency can be higher. But there is a difficulty in the parallel hybrid is control architecture is difficult or complex in the parallel when you compare with the series hybrid. So due to the mechanical coupling between the engine and the driven wheels is more important to control in the parallel hybrid. Then how the levels of hybridization will happen? So which is first, if you can see, from 3 kilowatt to 120 kilowatt of machines, how they are giving and what are their example vehicles available. And if you see 3 kilowatt only start stop function, which we discussed, start stop, and start stop with regenerative braking is called micro hybrid. And if it is having boost function plus these two, then it is mild. And if it can drive electric plus these three, then it is called electric drive with a limited. And electric drive plus these all features may be plug-in or fully hybrid. So these are some of the examples for the powertrains you can see at the outside market available in, and finally, the challenges with respect to hybrid electric vehicle are, however, with the present technology, due to the range which can give, and the hybrid is limited because of the energy storage element available in the vehicle, which are nothing but your onboard batteries. And with hybrid, the vehicle weight will increase when you compare with your conventional vehicle, that is limited payload and volume capacity due to heavy and bulky batteries, and longer battery charging time is required for HEVs. So if this can be achieved, then there can be a lot of advantages when you compare with your conventional vehicles to move forward in the hybrid electric vehicle domain. And with this, I end here. And if you have any questions, I'm open to take.
Thank you, sir, for a great presentation. Uh, Now, I'd request the audience to bring forth any questions that might have risen during this session, either in the chat box, or you could just raise your hand and our team shall give you the option to unmute so that you can ask the question. Okay, so we have a first question from Vanamuk Giridhar Kumar. Giridhar, you could just unmute and ask the question.
Hello, sir. Am I audible? Hello,
You're right. Yes.
sir. What do you think of the cost if we include motor and the battery to make it hybrid? And how much will it increase from the conventional one?
Could you repeat your question?
Sir, we are just adding the battery and the motor and some other additional features to improve the efficiency. And how much cost will the capital cost will increase from it?
That depends on your vehicle capacity, because it is either you are taking a four wheeler with a limited features, or it may be with a high end model. So that depends in the market. It is having from 2 lakhs to different configuration, because it first depends on what kilowatt of machine you are going to introduce into your vehicle. If it is a 3 kilowatt machine, or a 5 kilowatt machine, or a 10 kilowatt, or a 25 kilowatt. And if you are going with that, then your battery size will change. What kind of battery, what is the kVA of battery you are going to use? So these are the features it is going to help you to analyze the cost on the vehicle. So typically, if it is a 3 kilowatt or 4 kilowatt machine, then the machine cost alone will cost below 10,000 rupees, or at least 5,000 rupees if it is a bulk mode. But if you are going for a single machine, then it may cost. Then the power electronics component, then your cooling system, then your battery. So, and reconfiguration on the vehicle. So different parameters will add cost. Based on that you can analyze, but you cannot say particularly this is overall cost for this particular system. If you can take a vehicle and you can analyze, this is my requirement, based on that we can estimate the cost. Yeah. hope I answered
I'm
your question.
yes, I'm sure Giridhar must be satisfied with the answer. So we have our next question from Sandeep Verma. Sandeep, you could just unmute and ask the question.
Sir, I have a very basic question. That is, how much maintenance would a hybrid vehicle need in comparison to a fully electric or an internal combustion engine vehicle?
See, maintenance as far as it is concerned, just like a conventional vehicle, but as I told, it depends on the configuration. The mechanical couplings may be very important in terms of hybrid electric vehicle. Certainly, the parallel configuration. Okay, so and those are the complex mechanical connections may have, but as you know, the power electronics component and electric machine will come up with certain warranty, like at least 5 to 10 years.
I hope your question was answered, Sandeep.
Got
So
it.
we have our next question from Tomata Sharwani Reddy. Okay, so Sharwani could just unmute and ask the question.
Hello, sir. I would like to ask a question about fast charging. So, to save time and when there's no time, we opt for DC fast charging option in few hybrid vehicles. What is your take on that fast charging? Does it assure the same kind of performance as the usual one, usual charging?
See, especially the hybrid, as you conveyed, good point that fast charging is meant for pure electric vehicles rather than hybrid electric vehicles, because uh, capacity on the hybrid electric vehicle battery will be less when you compare with the electric vehicle. And second thing, and how do you take this compare with the usual charging? So there are certain indications when you charge with very high, because fast chargers are rated beyond 100 ampere rating, correct? So definitely the time will reduce, but the chemistry in the material will definitely impact with the fast charge continuous or in the day to day. People generally goes fast charge when they it is must requirement, but definitely there will be some impact to battery life when you charge. You can simply do an experiment in your mobile chargers today. When you charge with the uh, take two mobiles, one you try to charge with the fast charging method, and one you charge with the conventional charging. Definitely you will identify the difference between how the battery performance for a after 6 months. So this example you can take, because the same lithium ion chemistry only we are using in the mobiles also. So that only has been taken, but in the different sizing or different packaging type will be used in the uh, hybrid or electric vehicle topologies.
Thank
Okay.
you, sir.
Yeah,
Thank you, sir, for answering those questions. There were a lot more questions than these, but we are on a tight schedule, so we aren't able to ask the participants to ask their questions. I'm sorry for the I'm sorry if if your questions were not selected because we are on a very tight schedule. So it was a wonderful interactive session indeed. Thank you, sir, for answering all the questions with utter patience and for giving us your valuable time. We look forward to hosting you in our upcoming events as well.
yeah. Thank you. Thanks again, NIT Durgapur SAE student collegiate, and all the organizing members, and wish you all the best for future events. And thanks a lot.
Thank you, sir. Thanks a lot.
Thank you. Bye bye.